Hello, welcome back. Today we're going to be talking about the x and y axis intercepts and the standard form of a linear equation. The objective: by the end of this video, you should be able to find the x and y axis intercepts of a linear equation and graph a linear equation in standard form. So, starting off with our first two vocabulary words, one of which we've already seen, the x-axis intercept is a point where the graph of a line crosses the x-axis. The y-axis intercept is a point where the graph of a line crosses the y-axis. I'm going to do the x-axis intercept in red. Let's find where the line crosses the x-axis. The line crosses the x-axis right here at the point 2, 0. So the x-axis intercept is 2, 0. Notice when I wrote the point for the x-axis intercept, I wrote some number, 0. That's because the x-axis intercept will always have a y value of 0. Let's find the y-axis intercept. That's the point where the line crosses the y-axis. I'm going to write that in green. The y-axis is crossed by the line at 0, 4. So the y-axis intercept is 0, 4, and notice, when I wrote the y-axis intercept as a point, it's always going to be 0, some number. Go ahead and try this one on your own, pressing pause, and when you're ready to see the answer, please press play. This graph crossed the x-axis at -6, 0, so that was our x-axis intercept. And the graph crossed the y-axis at 0, -4, so that was our y-axis intercept. Go ahead and try this one on your own, pressing pause and press play when you're ready to see the answer. Notice how the line crosses the x and the y-axis at the exact same spot. They both cross through the origin, which is 0, 0. This is a special case, and notice how it causes our x and y-axis intercept to have the exact same value, because again the line crosses the x and y-axis at the same point. Suppose we're given just an equation and not a graph, and we're asked to find the x and the y-axis intercepts. Well, think about what you know about the x and y-axis intercepts. For the x-intercept, it's always going to be some number, 0. For the y-intercept, it's always going to be 0, some number. But how would that relate to the equation? Well, the answer is, since you know that the x-intercept always has a y value of 0, we can find the x-intercept by substituting 0 in for the y. This would give us 3x minus 4 times 0 equals 12. And again, the reason we can do this is because we know that the y value of the x-axis intercept is always 0. This allows us to create an equation that we can solve for x. So 3x minus 4 times 0. 4 times 0 is just 0, so 3x equals 12. We divide both sides by 3, and we get x is equal to 4. This means our x-intercept is 4, 0. We found the x value by substituting 0 in for y. What about the y-intercept? Well, the y-intercept is going to be a similar process, except we don't know anything about the y value. What we know for the y-intercept is that the x value is always going to be 0. So it gives us 3 times 0 minus 4y equals 12. 3 times 0 is just 0, leaving us with negative 4y is equal to 12. We can then divide both sides by negative 4, giving us y is equal to negative 3. So our y-intercept is going to be 0, negative 3. And again, the way we found the y-intercept is we put 0 in for x. So to summarize, to find the x-intercept, we're going to substitute 0 in for the y in the equation, and then solve for x. To find the y-intercept, we're going to substitute 0 in for the x in the equation, and then solve for y. In other words, you put 0 in for the opposite letter you're trying to find. Go ahead and try to find the x and y-axis intercepts for this equation. Pressing pause when you're ready to see the answer, please press play. So to find the x-intercept, we put 0 in for y, leaving us with negative 2x plus 5 times 0 equals 20. Leaving us with negative 2x equals 20. Divide both sides by negative 2, and we get x is equal to negative 10. So our x-intercept is negative 10, comma 0. To find the y-intercept, we're going to substitute 0 in for the x value, and then solve for y. So I put 0 in for x, negative 2 times 0 plus 5y equals 20. Negative 2 times 0 is just 0, plus 5y leaves us with 5y equal to 20. Divide both sides by 5, and we get y is equal to 4. This means that our y-intercept is 0, 4. This idea of x and y-axis intercepts and finding them from an equation leads us to the standard form of a linear equation, ax plus by equals c, where a, b, and c are any real numbers except for 0. Taking a look at the standard form a little bit more closely, we notice that the standard form is the first form of an equation of a line that does not give us a slope to use when graphing. Well, that's important because when we were graphing the other forms, point-slope or slope-intercept, we were given the slope to use in order to graph. But thinking about intercepts, how could you find 2 points in order to graph the linear equation? Think about that question as we move on to the next section. So thinking about the question just asked, how would we graph a linear equation that's in standard form? The answer is that we find the x and y-axis intercepts, and then we graph the line. So if we're asked to graph the following equation, negative x plus 5y equals 10, all we need to do is find the x and y-axis intercepts, which I'm going to abbreviate as xint and yint. We're going to plot those 2 points on a graph, and then we're going to connect the points with a straight line. Go ahead and find the x and y-axis intercepts, pressing pause, and when you're ready to see the answer, please press play. For your x-intercept, you should have gotten negative 10, 0. For your y-intercept, you should have gotten 0, 2. Let's go ahead and plot those points. Negative 10, 0. And 0, 2. Note, we now have 2 points that are on the line. 2 very specific points, but it does give us 2 points. If we connect those 2 points with a straight line, we've managed to graph the equation of the line that's in standard form, again, by finding the x and y-axis intercepts, plotting them on the graph, and connecting them with a line. You try. Go ahead and graph the following equation by finding the x and y-axis intercepts. Alright, I went ahead and found the x-intercept by putting 0 in for y, solving for x. Then I found the y-intercept by putting 0 in for x and solving for y. I plotted the 2 intercepts and I connected them with a straight line.